Hello and welcome, dear friends. In this video we are going to talk about how ground regiments will move. Ground regiments will go around the mountains and water hexes. A hero will slow down, passing the desert, and will stop when it gets into the swamp. We will learn how to rotate a hero horizontally. Now a hero is looking in one direction only, and if I click on a hex which is in the opposite direction, then a hero performs a moonwalk. It would look great if we were dancing in a disco, but I doubt a player will appreciate our dances. Let's get started. Let me press the play button and select a target hex. If I change my mind and click on another hex, I will see that some of the hexes haven't changed color. There is no need to tint the optimal path. This is a temporary solution, but for now it's important to tint the optimal path correctly. Let's fix it. Open Click on Me class. Clear previous selection of target hex method is a member of Click on Me class. Here I will add only one statement, referring to the landscape variable. I will change the color of all hexes included in active hex list. I simply return the default color and transparency. Let's see how it goes. Good. Now it's better. Open Hero Prefab. I noticed a short pause between clicking on the hex and the start of the flight animation. Select Animator window and select Transition between idle and movement clips. Remove the check marks from the Has exit time and fixed duration fields to exclude pauses between mouse clicks and animation clips. I'm sure it's better now. Now we are ready to flip a hero. Open Move script. I will create a new method inside the Move class. Let's name it Control Direction. The method needs a parameter, which is the target hex. So what is next? Let's have a look at the properties of the Sprite Renderer component. Sprite Renderer is attached to the Hero prefab. Here we have a property that rotates a hero horizontally and vertically. It is a flip property. If we get access to the property, then we will be able to flip a hero horizontally. Okay, when we flip a hero? Obviously, we flip a hero when a new target hex is being determined. So I will call the method inside the reset target position method after we define a new target position. And the position of the target hex is going to be a parameter of the control direction method. But how to explain to the hero which way a hero should turn? Well, let's imagine a hex and all 6 options that a hero can choose. Each hex has a global x-coordinate that determines the position of a hero along the x-axis. If an adjacent hex is placed to the left of starting hex, then x-coordinate of the adjacent hex is less than the x-coordinate of the starting hex. And vice versa. If an adjacent hex is placed to the right of the starting hex, then x-coordinate of the adjacent hex is greater than the x-coordinate of the starting hex. We can use this to explain to the hero which way to turn. Let's find the difference between the two coordinates, subtract the coordinate of the neighboring target hex from the coordinate of the starting hex. And if this difference is negative, then we turn a hero to the right. If this difference is positive, then we need to turn a hero to the left. We'll rotate a hero by changing the value of the flip property to the opposite value. The nuance is that we will not know exactly in which direction a hero will look at a particular moment. Before a hero starts moving, a hero can look left or right. We need to come up with the idea so that the code doesn't depend on the current position of a hero. Let's go for it. I will declare a new variable of type bool, let it be internal, and let the default value be true. We'll adjust the value of this variable when we place heroes first time. But now the fairy is looking to the right. And I need access to the sprite render component, declare a variable and assign a value to it here inside the start function. Now I can move to the method we recently created. We have two possible situations when we need to flip a hero. The first situation is when the coordinate of the adjacent hex is less than the x-coordinate of the starting hex, and a hero is looking to the right. The second situation is when the coordinate of the adjacent hex is greater than the x-coordinate of the starting hex, and a hero is looking to the left. I use the OR operator. It's important to understand how this operator works. The operator OR evaluates the whole expression on the left side, and if it is true, then and only then it evaluates the whole expression on the right side. So we determined two possible situations. Now we can reverse the value of the looking to the right variable and reverse the value of the flip x variable. It is a property of the sprite renderer component. Good. Go to Unity and check how it goes. Well, it is much better now. Before I dive into the main part of this video, let me clean up a few more little things. Open battle controller script. I'm going to refer to the current attacker, so let me make sure that I find the hero object before I refer to it. Instead of start function, I will use the awake function. Now go to field manager script. Get available positions method uses the hard number. This hard number defines a hero's velocity. It is not a very good idea to use hard numbers, so let me use a variable instead. I will declare a variable of integer type and refer to the current attacker. Current attacker is a member of battle controller class. I will replace the hard number with a variable we have just initialized. Good. Make sure that we refer to the positions for ground class. Imagine for a while that a fairy has forgotten how to fly. There is the last preparatory step to be taken. Open the battle hex class. Here I have defined me as starting hex method. I will add one more statement and set the value of the distance from starting point variable to 0. Well, I'm going to change the default value of this variable for all hexes except for the starting hex. The value of the distance from starting point variable for the starting hex must remain equal to 0. Okay, let's move on to the main topic of this video. Ground units have behaviors different from flying units. We created a class that will take this into account. It is positions for ground class. Let's think about the changes we need to make. So, unlike flying units, swamps and deserts influence the behavior of ground regiments. This means that a steps to go variable, that is a member of the distance class, must be taken into account. Now the value of the steps to go variable is 1 for all hexes. And this is good for flying units, but it's wrong for ground units. Therefore, we will need to set individual values for the steps to go variable. The second important difference is that I have to count the distance from the starting point for flying units for each hex, including water and mountains. This is necessary because flying regiments can fly over a mountain or water. In this case, water and mountains cannot become a target position, but can be a part of an optimal path. Ground regiments cannot fly over a mountain or water, so the mountains and water cannot become parts of the optimal path. And as a result, we will not be able to select these hexes as a target for movement. To solve problems, we can use Boolean variables and if statements. And there are no serious flaws in this decision, but I will try to use a different way. I want to use the structure that we created to handle such kind of issues. Okay, let's start with the battlefield. I will replace two hexes. We have a large swamp that consists of 7 hexes, and there is a large lake that consists of 7 objects. In order to make the code more universal, I want to check it on single objects. To replace the hex selected, copy its rect transform component, then select a hex prefab and holding the Alt button, drag the prefab onto the hex that we want to replace. Then paste the rect transform component, and I will repeat this one more time. Let me first move the hero to the middle of the battlefield, closer to the water and swamp. Don't forget that the hero must be a child of a hex object. Open the desert prefab, select the distance text variable, set the value of steps to go variable to 2. Now open the swamp prefab and set the value of steps to go variable to 10. The number must be big enough to stop the movement of a hero. The value can be equal to 50. It doesn't matter, you can make the value of the variable less than 10, because the velocity of any hero is unlikely to exceed 5, but it really doesn't matter. Let it be 10. And until we get to the scripts, I'll make another change. Open the distance hex prefab. I'm going to set the value of distance from starting point variable to 20. I will explain why I did this a bit later. Back to the positions for ground script. Now this class simply copies the behavior of flying units. The neighbors to check list collects neighboring hexes that meet certain conditions. The conditions are defined by if it is a new hex class. One of these conditions is the condition that the value of the isNeighboring hex variable must be false. This helps us identify the hexes we have already evaluated. Inside the getAdjacentHexes extended method, we set the value of the isNeighboring hex variable to true. For that reason, when we look for neighboring hexes for another hex, we do not evaluate the hex whose isNeighboring hex variable is true. We exclude re-verification, or let's say we don't recheck the hex. Then, calling the setDistanceFromStartingHex method, we set a distance from starting point variable to the hex included in neighbors to check list. In fact, since the value of steps to go variable was 1 for all hexes, we just added 1 to the variable. And it worked great for flying regiments. And this will not work for ground regiments. Why is that? Let's imagine a situation where we're looking for neighbors for hexes that are included in the neighbors to check list. Let there be 2 hexes to simplify. One of the hexes will be a desert, the other a plain hex. Both hexes will be equidistant from the starting hex. Let the distance from starting point variable value for both hexes be equal to 2. The steps to go variable of the desert hex is equal to 2. For plain, it's 1. We don't know the order of elements in neighbors to check list, therefore the first hex for which we are looking for neighbors may be a desert. In this case, the value of the variable for neighbor, that is between plain and swamp, will be 4. We will set the value of the isNeighboring hex variable to true, and next time we will not check this hex. Therefore, the value of the distance from starting point of grass will remain equal to 4. But it is obvious that the distance to the grass hex from the plain is less, and it will be equal to 3. 3 is the right value, 4 is the wrong value. The solution here is quite simple. In the case of ground regiments, we must recheck the hexes. We don't need to recheck hexes whose isIncluded variable is equal to true, but this time we must ignore the value of isNeighboring hex variable. We have a class that evaluates hexes. It is if it is new hex class. Now it works great for flying regiments, so I will rename it. The new name will be if it is new flying. I will create a new script and name it if it is new ground. It also will implement an iEvaluateHex interface, therefore I need to have evaluateHex method. The first 2 conditions repeat the conditions written in the if it is new flying class. As before, it makes sense to exclude hexes that are already defined as available positions. This time I use isIncluded variable. We'll discuss the last condition a bit later, now let it be inactive. Back to positions for ground class, let me refer to the if it is new ground class when I choose the behavior of evaluateHex method. Here, before I set a value to the distance from starting point, I need to evaluate the current value of the distance from starting point variable, and call setDistanceFromStartingHex method and make me available method only if the current value is bigger than the value we want to set. Well, let's create this method. Let it be a member of distance class. I named the method evaluateDistanceForGround. The method will return boolean, and I have passed one parameter or battlehex type into the method. It stores information about the hex for which we are looking for neighboring hexes. I named it initial hex. The local integer variable currentDistance stores information about the number of steps needed to get to the initial hex and to get out of it. The steps limit variable refers to the hero's velocity. Hero's velocity limits the number of steps a hero can take. To return the true or false value, I check 2 conditions. The first condition compares the current value of distance from starting point variable with the value we want to set to it. If it is true, then we found a shorter way than before, and we can set a new distance. If it is not true, then we will not change the value of the distance from starting point variable. The second condition compares the velocity of a hero with the number of steps needed to get to the initial hex and to get out of it. If it is false, then this means that hero's velocity is not enough to reach this particular hex. And we will not set value to the distance from starting point variable, and we will not include this hex in the group of hexes available for movement. Back to the positions for ground script. I can add an if statement and refer to the method that we have just created. If the method returns a true value, then the hex can be defined as a possible position. That's not all that we have to do, but let's check it out. Let me select the hero prefab and set the velocity to 5, for example. Press the play button. Well, not bad. Deserts and swamp behave correctly. And fairy moves correctly if a fairy is not moving through mountains or water hexes. Let's fix the behavior of water and mountain hexes. Open the battle hex script. Mountains and water are derived from the battle hex class. Well, I can use boolean to define if a hex is available for ground regiments or not, but I will use a method instead. Let's practice inheritance this time. I have created a method that returns boolean. I have used the virtual keyword to force C# to check if the method is overridden in child classes. The method will return true value for all classes except water and mountains. To override the behavior of the available to ground method, I will use the override keyword. Water and mountains will override the method of the parent class. Good, now open the ifItisNewGround class and let me activate the last statement. If it is true, then we execute the code block of if statement written inside the getAdjacentHexes extended methods. We set new distance to the hex, set true value to the isNeighboring variable, and call makeMeAvailable method. Let's check it out. Remember that fairy should move as a ground unit for a while. Try to move it. And now it's better. The last thing we have to do is check the behavior of the flying regiment. I made one significant change that affected the flying regiment. I have adjusted the value of the steps to go variable. Now the variable value for the swamp and deserts is not 1 anymore. Open distance class. Set distance from starting hex method is a member of distance class. Its code block is fine for ground regiments, but the flying regiment should ignore swamps and deserts. Let me rename the method. Let it be set distance for ground unit. Now I will select the last two statements and extract a new method. Let me name it displayDistanceText. And I will create a method for flying regiments. Name it setDistanceForFlyingUnit. The method will do almost the same thing, but it will ignore the value of the steps to go variable. I will write 1 instead. Open positions for flying script. And instead of setDistanceForGroundUnit method, I will call setDistanceForFlyingUnit method. Now open the field manager script and make the fairy fly again. Let's see how it goes in Unity. Well, we can assume that the movement of the flying regiment is restored. Good. 2 other significant points need to be taken into account. The positions of an enemy and friendly regiments will also influence the movement. And an enemy computer will choose the target position without clicking on the hex. This is also a very interesting task, but to solve it, we need to create more heroes. Have a rest, see you in the upcoming video.